Alright, today we learned how to find the perimeter and area of triangles, trapezoids, and rhombi. So a triangle is a polygon with 3 sides and 3 angles whose sum is 180 degrees. So all our angles add to be 180 degrees. Then we talked about if we add 2 angles and they add to be 180 degrees, they're known as supplementary. And if we add 2 angles that add to be 90 degrees, they're complementary. So that's just a good review of some vocabulary. Trapezoid is a quadrilateral with exactly 1 pair of parallel sides called bases. So we can see that these sides are the ones that are parallel, so they're called bases. The other non-parallel sides are called legs. Eventually those 2 legs, if we were to extend them, alright, that one's better, then we would see that they would meet. So that's how we know they're not parallel. They're called legs, and sometimes those legs are congruent, but not always. And if they are congruent, they will show that. A rhombus is a quadrilateral with 4 congruent sides whose diagonals are perpendicular. Let me try that again. So these are perpendicular. Some things to note is they also bisect each other. So this side, if it were 5, would be the same as this side. And the side above here, that if it were 4, it would be the same as this one down here, 4. We have 3 different area formulas today. The first one is the area of a triangle, and it's half your base times your height, or you could take your base times height divided by 2, and it's important that the height must be perpendicular to the base. If we have a right triangle, then we can see that the base and the height are already perpendicular, so that's how we would label those. But if you have a triangle that is not a right triangle, then we would have to find that height so that it was perpendicular to the base. A trapezoid is this formula, half the height times base 1 plus base 2, or it can look like this. You can add them, multiply by h, and divide by 2. And we talked a lot about this is an average right here of the 2 bases. We know that the bases are parallel, so we're going to add those and divide by 2, and that's where that formula will come from. We'll multiply by the height. The height has to be perpendicular to both bases. And then the last one is the rhombus, and we're going to use D. D represents the diagonal. So you're going to take half of D1 times D2, or I just say D1 times D2 divided by 2. And those are equal expressions. Okay, so example 1, find the perimeter and area of each polygon. The first thing you want to do is identify the polygon. This first one here is a trapezoid. And we're going to find the area and the perimeter. The perimeter, all we do is add up all the sides. So we can see we have the 2 bases, but we are missing the legs. So we're going to use what we know from this. If I were to draw this down, we can see that we would create a rectangle right there. And because it's a rectangle, opposite sides are congruent. So we would know that the bottom piece right here is 20. And we also know that the entire base is 38, so if we subtract 38 minus 20, then we get 18. And if we divide that by 2, it gives us those leftover pieces. Then we can use this right triangle. Sorry about that interruption, but we can see that we have this right triangle here. And we can use the Pythagorean theorem to find that missing side. So we can take 9 squared plus the 40 squared and set it equal to c squared. Then from there we take the 81 plus 1600, add those together to get 1681, and then take the square root. And that gives us 41. So we can see that this side is 41. We have 2 sides that are 41, and then we're going to add all of that up to get 140 units. Then from there we'll find the area. Because it's a trapezoid, we'll use our area formula that says we take the height, here it's 40, times base 1 plus base 2, and then we'll divide by 2. So then we take 40 times, we add those 2 to get 58 and divide by 2. And we get an area of 1,160 units squared. Okay, so we're now going to look at our next shape. Our next shape is a rhombus. And with a rhombus, we can find the perimeter. The perimeter, we add all the sides, and all the sides are the same, so we take 26 times 4, which gives us 104, and here it's meters. For the area, we take half of diagonal 1 times diagonal 2, or diagonal 1 times diagonal 2 divided by 2. So we're going to look. We can see that we have half of the diagonal, it's 10, so the whole thing is 20. But we need this other diagonal. Okay, what I see here is a right triangle. And because we have a right triangle, we're going to use that 10 squared plus b, we'll call this b, squared equals 26 squared. Use the Pythagorean theorem. So we have 100 plus b squared equals 676. Subtract 100, we get 576, and then take the square root, and b gives us 24. So this height is, or that part of the diagonal is 24. To get the entire diagonal, we multiply that by 2 to get 48. And then to find the area, we take 20 times 48 and divide that by 2, and we get 480 meters squared. For example C, we have a triangle, and it is important to recognize that this is the triangle we are using. This other information is just extra information that probably will be needed later. So we start out by finding the perimeter. To find the perimeter, we add up all the sides. So we have a 12 and a 35, but we are missing this side length here. And we can see that we do have a right triangle, so we can use the Pythagorean theorem using 7 squared plus 24 squared equals c squared. So we have 49 plus 576 equals c squared. We add those together and we get 625. Then we take the square root to get 25 equals c. So the other missing side is 25. We add all those up and get 72 inches. Then for our area, we're going to take the base times the height divided by 2, so our base is 12. And the height has to be perpendicular, so we can see that here is our perpendicular to the base, so we're going to use that 24. So times 24. We take the 12 times the 24, divide by 2, and we get 144 inches squared. Okay, on example 2, the first thing you're going to do is graph it, and then it asks you to find the area of the trapezoid. It tells you have a trapezoid. So to find the area, we need to know some lengths. With this one, we first are going to find the bases, and the bases are horizontal, so we can just count that length. From A to B is 6, from D to C is 11, and then the last length we need, or distance, is the height, and we can just count that as well, and that's 5. So for our formula, we take our height, 5 times base 1, 6 plus 11, and then divide that by 2. So we get 6 plus 11 is 17 times 5 is 85, divided by 2 is 42.5 units squared. On example 3, I've already graphed it here, and it asks us to find the area of a rhombus. To find the area of the rhombus, you need to know the lengths of the diagonals. So, wow. Got a diagonal there and the diagonal here. From E to G, we can just count that. That's a 6. And then from F to H, again, we can count that. And that's 8. So to find the area, we take half, or divide by 2, of diagonal 1 times diagonal 2. So our area is 24 units squared. If we couldn't count those, if they were not horizontal or vertical, those distances, then we could either use the distance formula to find it, or we could start drawing some right triangles and use the Pythagorean theorem to find them. Okay, example 4, it gives us a rhombus, and it tells us that it has an area of 100 square meters. It tells us that XY here has a length of 10, and so we're going to use the area formula because it tells us it has an area. So 100, our area, equals diagonal 1 times diagonal 2 divided by 2. So diagonal 1 is 10 Diagonal 2 is WY, and that's what we're trying to find. So there's a couple ways. I would probably just divide those. A couple ways to solve this. 10 divided by 2 is 5. And then divide by 5. And WY is 20. If you wanted to multiply by 2 in the beginning and solve it that way, that's fine. Alright, that should help you with your assignment 8-4, triangles, trapezoids, and rhombi. I put a rhombus there. Good luck.